And today I want to do a project that I've been thinking about for a long time. And it is this idea of actor model that is really popular in Erlang because it was basically popularized by that language and the whole ecosystem, how everything works in Erlang. And it was created by Carl Hewitt. I think that's how we pronounce it. And the idea is to have an actor that receives messages and then has an internal state, and then using those messages you can update that state. So you don't need exactly a locking mechanism for doing multi-threading. And another benefit that Erlang has is, so this is for the actor model. So about Erlang, they say that you can have supervisors where you can set up a strategy for dealing with errors. So if one actor is running, then something bad happens and then it fails, you can set for doing some kind of logic to, maybe you want to retry some amount of times, or maybe you want to log an error, or like you can do a lot of stuff, and then it's isolated to that actor, so it doesn't affect the whole system. So this makes possible to be fault tolerant. And so Erlang itself it runs on top of VM, and then they say that they can support for like thousands, like almost a million, I don't know. I think this processes, yes, process. So they call processes each actor, so they can have a large amount of that. And if you think about in a basic understanding of the underlying system, because that number of processes, that it is a lightweight process, it's not a system process, but it runs on a VM, and you need to think that all of that, both the VM, that code that you wrote in Erlang or in Elixir, needs to be translated to the underlying system. So the underlying system, it is has some specs. For example, you could have a PC with 16 gigabytes of RAM. Maybe mine has 16 gigabytes and also 12 cores, which is also the specs of my computer. And you having a large amount of process, even lightweight, doesn't really translate exactly to the system, because you have a fixed amount of physical stuff that you can do. So even though you have like let's say 100,000 process, you can't physically run a thousand in parallel, for example. You need to be concurrent, but you can distribute that on the threads, on the amount of threads you have on your machine. And that's basically what it happens behind the scenes. The whole system of Erlang take cares of that, and it is nice, but I was thinking about how would how it would be to do without any abstractions, like really going down to the basic implementation of this. And so I can close this, and I did something, but I was not streaming, and I created an actor module in C, and you can see that it is like 87 lines of code. It's really small for something that is really cool. I really like it when I finished, and it works really nice. And the basic idea is that each actor has his own state and also a mailbox. So this is the whole trick of this idea. So instead of communicating directly, you send messages, and that message is you send to that mailbox. So you have maybe a fixed size of number of messages, and then the actor continually look for those messages and process them. You can see down here on the run actor function, I have an infinite loop because this is running in a thread, and I see if there is any message, and if there is a message, then I compute, in this case, the message and decrease the amount of messages. So that was the first part of the puzzle, to get to understand exactly what it would mean to have an actor and to design an actor model. You can find several libraries in several languages, even in C, about this actor model. But I want to do a very simple example of how it would look like. And I really liked this function. So you can see that for processing the message, you don't need any locking mechanism, because it's the actor itself is the only one that is processing, is touching that message. So there is no other actor messing around. However, you need a way to send those messages. And how do you send? And I really liked, first I used a mutex, and it worked. Then I started to think about how to remove it, and I managed to do in basically 3 lines of code. So that's really, really cool. I really like this function. And you can see that I use 2 interlocked functions. They are basically instruction on the CPU that this basically translates to a single instruction on the CPU, especially I think for x64. And what this does is, the first is the value that you want to write into. So you need to have a volatile, in this case a write index, so I keep track of the index that I can write to that mailbox, and I have also a total message. So you can see that read index, I don't need volatile because it is not used in this type of functions. So the first one is the value that I want to write into. I think that's Wait. I think I'm. Let's see the documentation. So yeah, so the destination, the value that you want to exchange to, and a value to do the comparison. Where is here? So this, so I want to compare this one with this one. So you can see that actor index is the same here. So I basically want to compare to itself. And this function is, so this instruction is guaranteed to no other thread to mess around with this, with the order. So every call to this, even if it is multi-threaded, it is scheduled to run one after another. So you don't have any race conditions here. And basically I see if they are both equal, then I update to the next. Here I do a module for wrapping around. So the mailbox is actually a circular buffer. So you have the write index and the read index. So you can see that you can write, and then you reach around here, and then read, and then you can wrap around the write index. And then what this returns is the value before the change. So it returns the actual actor write index. So basically I can guarantee that this thread that is sending a message is guaranteed to get an exclusive index to write into that mailbox. So no other thread will have the same index. And that's really cool because you don't need any kind of mutex, semaphore, or anything like that. It's just a simple function. And after you have this write index, you can copy. So it's basically I grabbed that index and only that thread has. You can send that message. So I do a mem copy of the message to the mailbox of the actor I want to send and the size of the message. And then I signal that, so I increment in an atomic way. So yeah, these type of functions are called atomics. And this is incremented in an atomic way. Then I basically signal that this, you have a new message, and then it can process that. So I really like this function. So that's basically the whole implementation. Then I do a test here where I create two actors, and then I send a message to the first actor, and the next actor send a message to the first one. And I have also a global actor list, and they basically send each other's messages. And so this is the first part of the puzzle. And another part, it is related to asynchronous I/O. Let's see. So in the previous streams, I made a multiplayer asteroids, and I used non-blocking sockets. You can see that it is just a function call with the sockets and setting non-blocking. And what this does is when you receive a message from the network or send to the network, like this, for example, right. Okay, so here I receive, and there is also a send. So it doesn't block, it doesn't, for example, receive, it doesn't stall the execution here, it continues executing. So you can basically process a lot more messages. The exact way how it works, I really don't exactly know. But the basic idea is that it doesn't stop when you call this function. It continues executing, and you can basically process a lot more of, because you can process a receive and then continue executing and then send everything. I don't know if you need to wait for completion or how it does, because you could call this function and then this actually hasn't finished executing, but since it's asynchronous, running locally, I never had any issue, so I don't know. And then this is the second piece of the puzzle, you could say. And the final one, it is related to how you can retry the execution of the actor if something fails. And I was looking, and there is a way to do that. In this case, is specific for Microsoft, for the Microsoft compiler. You have this try, except, and finally, where it can raise both hardware exception and also a programmable exception. For Linux, you have the signal events. I think it mentions here signals. So basically, you could do the same thing on Linux. So I can close this. And let's show what this looks like. So you can see that I have a main function, I create a thread, and I have an exit code. I get exit code from the thread, and if it needs restart, I just set false because it didn't restart. So if I should restart, then I reset, and then it ends the loop, the while loop, goes back and restarts. If it doesn't need to restart, the thread finishes, so it breaks out and executes this thread function. I receive as argument this should restart, and I just print an ID. Let's actually run this. Okay, it's configured to run another I have several other files in this project, so it's just for testing stuff. Okay, so but basically it tries to, in this case, dereference a null pointer. So it receives that exception, prints the error, and then I just sleep for a few seconds, clear the screen, and then return exit failure. So it will get the exit code here. Close the thread and then create a new thread. And then this actually works. It's really cool. So you can also have a division by 0. Then this will catch that exception. So you can see that you can also specify what type of exception you want. So in this case, I want to capture basically every exception. And when I got these all these pieces of the puzzle, I needed to put together in a cool way, in a cool project. So since Erlang it is very used in scalable web servers and that kind of stuff, I want to do the same thing with the pieces that I managed to get. And the idea, so before that, I want to explain the idea. So I want to have, for example, if I have 4 threads, okay, let's have, this is the mailbox. And I have the threads. So let's say I have 4 threads. So what I want to do is each of them is a actor. Yeah, hard to read, but okay, it's an actor. And that would implement that mechanism of failure. So it will have a try catch. And receive on. So basically, maybe I want to have one more that would be the main thread. And the main thread will schedule to all of these threads. So it receives a message. So from, I don't think it needs a mailbox, but you receive from the network, receive. Then I check, so I do a for loop to check the total message. So which one has the fewer messages? Then I send that message to that thread, or to that actor. So that's the basic idea. And because you basically scale accordingly to every thread that you have, and that's basically how the Erlang do in behind the scenes. But this is way more I would say, efficient, because you eliminate a lot of abstractions and also a lot of code that you might not need, and you can reach or get a similar effect and probably I would say faster implementation, because there is way less code to the CPU actually execute, because you have the VM and the language and all that. Here you just have a binary that will compile to the specific architecture that you're working with. So if you compare the amount of CPU instructions that both has to execute, I would believe this is way less, and I would say that would be way faster. But since comparing things, like, there is very it's not exactly easy to compare, because there's a lot different factors, and I want to point out, for example, this post for showing the that WhatsApp had 1 million connections, I believe. Okay, so it was over 2 million connections, and basically you have an option to define on the kernel the amount of connections. So there's a lot of nuance in doing this kind of optimizations. So it's not just the program that is running, it's also the kernel. And there is this other post that I like it. The secret to 10 million concurrent connections. The kernel is the problem, not the solution. And then the idea is to basically remove the kernel from the equation. So you have way less code interfering with your goal or with your software. And there is various ways to achieve these. I mentioned in the asteroids string that you can bypass the kernel, the user space kernel, the user space from Linux. So you basically, it's directly on the kernel. I think it's called X something. Let's see, X. I don't remember. There's also exokernel. I think no, it's not this. I think it's XBBK or something, where you can bypass the user space. So there is less code running between the message that you want to receive from your actual software. There is this also idea of exokernel, where it is similar to a microkernel, where you have a very limited OS running, that is basically with very limited set of features to interfere at the least amount of possible with the receiving and sending network packets. Let's see if a Gaffer on games, he mentions this one. Mass bandwidth. He mentions, I think it's XDP. Okay, yeah. So basically, you have a way express data path. You write to the earliest when the packet comes off the network interface. And there's also this other thing. It's for Linux. The bytecode lightweight window runs inside of Linux kernel. So this guy, Glenn Fiedler, he's very experienced in network programming, and so he knows that there is a lot of ways to optimize your application. So he mentions that it is one of the ways. He also has a working example. So just to show that it is not actually very easy to measure, because it's very different solutions to the same problem. Okay, so let's close this. And there's also configurations and network layouts, like the structure of the network, all come into play in the performance. There is also one thing that I think is nice to mention. There is a game, I think it's Dota, that the company created their own infrastructure for network, like real physical servers, to basically bypass everything from the regular internet providers. And there is a really cool, I think, creating your own network. I think Dota, maybe. Your own internet. No. I don't remember. There is a Gaffer on games. He mentions in one of his posts. Where is the? Okay, so the first one. Let's see if we can find. Articles. There's. I think it's this presentation. Private network. He basically also creates his own. Yeah, I can find. Yeah, I need to search before. Okay, so let's get back to the idea. 1 second. So this idea is actually implemented on WinSockets the I/O completion port. So I was reading what is the best way to do networking on Windows, and it seems that this is the best way, the most efficient and faster. And from what I read, it is receiving the messages in a asynchronous way, and it distributes between the threads. So it creates a number of threads, and then it's basically the completion part will take one thread to handle the events. Okay. So basically he does what I understand from reading about this is that internally you basically need to create the threads, and internally it will do this kind of schedule. So you don't need to worry about this and just write the functions. But I want to do, so I guess the internal implementation, it is something like this, where you have a mailbox, and then but from that Stack Overflow answer, it seems that it waits to one thread to be available. So instead of one several mailbox, it has basically one, and then it basically distributes for the threads. So yeah, that's, so you need to know a way to see if it's working or if it's idle. Yeah, that would be another approach. But I want to follow this idea, and I have some codes here that I can just basically copy paste. Have I set up a project. You can see that it's working. Let's copy this. So this is the server. Just need to remove a few things. So there's types. Probably we need to change a lot of types. So we can remove this. Okay, no, this is important. A list and so this accept, it is client index. Can delete this, delete this. Let's see. Receive, delete this. Send. So this is another. We can remove this, and second blocking, let's disable that. The buffer, don't need. Okay, so client indexes, max chips. So I don't think we need this. Also this. The types. Don't think I need this. Yeah, let's add the types. Okay. First. Just better types. Probably I want to, instead of file, because it's only the server that I'm interested. Can leave that. So this server sockets. Okay, so I need a number of maximum clients. Let's say define define max clients, and I don't know if, so there is a max connection. I think I could do this, right? I don't know how many is this. Let's actually 100 first. So instead of max chips, max clients, the client index. So instead of accepting client index, I set this. Let's copy this. And is invalid. Yes. Let's comment out. So we can move these here. Receive. Let's actually see if it connects. There is also the default port. I think there is also another thing, message buffer, default port. Let's copy this. And let's say, let's leave this. Okay, so first I want to test the accept. So basically I'm accepting every connection. And if there isn't a error, I want to set this. And let's print a message. Client connected. ID, let's say this. and client index -1, or just do this. I forgot if, and basically we'll try to, so this will be synchronous. You can see that if I print f after accept, let's add new line. So let's try to run this. Okay, a message for, let's change this to server is listing on HTTP localhost. The default port actually is a string, so the default port. Okay, so I can, it's connected only one, right? But it's connected to, is that, so you can see that it doesn't run infinitely. Okay, it doesn't receive any response. Let's actually change this to send hello world. Where is the, so I have another project that I followed the tutorial for creating a web server in C. And there is a way here to send response. You can also send a file. Then close the client. Response, client socket, wait written. So let's try this. I have this web server, so let's say actor web server. Thanks. I could do hello sailor. It failed because of this. Right, size is not declared. Okay, so let's try this. Right, and define it. So it's actually sends, right? Sends the buffer, the size, and 0 for whatever reason. Client socket, it is this one. So actually, size t, string length. So it's converting size t to int. So it's okay, it works, returns. And I think I need to close the connection. let's try this. So it sends, then close the it is not close. Web server. Let's see if it has. How it closes. Close sockets. So it's different. Close sockets. Okay, let's see. It tries to connect, but it fails. So a lot of connections. Yeah. But at some point I want to close the connection. So I think that's it for the server. Now I want to we can delete this. Actually this set from blocking. Okay. Close this. So I think that's let's receive. So I need a way to receive data from the client. So send it is return 32. Delete this. Let's see if it's working. Okay. Send result. Aborting. Okay, so this. Okay, hello sailor. Don't know why it connects 2 times. Okay, so now I want to commit this basic web server implementation. So let's actually get the message from the client. Say 10 and define message. Find index ID. So receive buffer clients. Receive. Okay, so let's say printf and received and s for receive buffer. So it crashes. Okay, so it received the headers and everything. Client connected. So this is what I receive: a get HTTP1 Windows. So basically, I want to listen. Because I want to send a number, or so to test the server, I want to send a random number, and this number would be 0. So it crashes the thread, then it can restart. So what I can do here is to we need to split. I'm thinking the easiest way to get that number. Let's say, okay, so it should work if I send like this, right? So you can see that I received this. So if I limit the size to 1 character, I could do 1, 2, 3, 4, 5, and then get this 6th number of the string. So basically I could do 6, but it is 0 indexed. Let's see if I, so close. Okay, so I want this. So 55. Actually, so received 7. Okay. Okay, so I'm receiving a random number and I want to I need to create those threads first. Let's start actors setup. So I want to create the number of threads that the system has, and there is a way to do this. And I have worked here the multi-thread test runner. So I have a way to count the number of threads. This can be U32 threads. U32 total threads. Okay. So I need to call a dynamic allocation for the size of a handle, which is the is the handle, is the type of the thread. So when you create a thread, it returns a handle. So I want to the number of the total threads. In here I can do a handle pointer threads. So I have an array of that. So it's initialized. I go through iterate I0 less than total threads I plus plus and threads I equals create thread. And I don't remember what is the arguments. Where's the create threads? So it's a lot of, so the function let's create thread proc or procedure in the threads args. Let's think. So for the thread proc, it needs to be a D word. I think that's the word. Threads proc, a void pointer for the args, and then I need to return 0. Okay, so this is the processing. So while true, I will run this. So basically I need to do this kind of thing. Let's actually copy this. So I'm thinking if I should use as an argument. I think that argument is better than a global array of should restart, because you are iterating through the array, so you have the index, so you can specify the index here. So think it's better to send the index, and I can do this. Should restart root, restart list. But I don't have a way to know the amount. Let's say like a big number, because I don't know the number of threads. Can be anything. Okay, so this all false should restart, and then instead of boolean, I send an index. Should restart index. I just print to see if it's working, and I need a try catch. Okay, so inside, it is inside. So actually I want to have a mailbox first, like in the mailbox. So I would need to pass this as okay. So actually here I grabbing this handler, this, so I can execute anything in here. The example tries to do in an external way to basically recreating the thread every time. But I think that I can put this on inside of the while loop, so it is constantly executing this. So try, and this catch is accepting this thing. So let's copy this and also copy. Restart. ID. So it will infinite loop in this. Which is fine. So it also needs the mailbox. Because instead of reading, I read from the mailbox. So create actor mailbox. So the run actor while true, message. So I need to pass the actor as argument and basically read from that. So instead of args, let's create a type def struct for, should be thread args. And here I want to have a mailbox. Let's say 1,000 integers. I need to know I don't need the should restart because every error I restart, but I need to know a way to know if it is restarted or not. Because if you continue this in trying that, so let's leave for later. What I want is the mailbox and also it's only the mailbox. Okay, so I can do this. Thread args. So while the args.mailbox, I need a total. This what I called total message. If total message created a 0, and I do another check. Let's see. In the read and is different than the write. So do not overwrite when you read a lot of data but doesn't write into, then you can accidentally read, in this case read something that you shouldn't. So it should never pass the right index. Okay, so also need a read index. Tile right index. Okay, so let's do the division. So A, it is this. Error detected. Restarting. So the b value is here, and I could do maybe b equals 1 to restart, and so it actually will start from here. Okay, so instead it should So I need to know a way if it's failed. If it's failed, then I should change. In this case, it doesn't really make sense to like redo. Let's maybe I could have a temporary variable and check if it is set or not. So if it is not set, then I read from the mailbox. If it's failed, or I could just use go to and go to here. So I bypass the reading of the mailbox. So args mailbox args dot read index. Probably I want the pointer to this. So args read index. So if I read successfully, I decrease the total messages, and the read index is this. So there is a capacity. Find mailbox capacity. And this. Total messages. Okay. That's basically it. Yeah, let's have 100. So I should restart. I don't need the thread yards, volatile, S32, right index. I do this. So he's received the arguments, have the thread ID, an infinite loop, then a loop for checking if there's any message. So it's a busy wait loop. Get the value. I need to get the value, try to do this. If it's successful, then I do this. And I basically set B to B1. Then I go to try again. And I can basically set this. Try again. So it will execute correctly, and then that's it. So thread proc I have here. So thread args, I need to store this size of threads are 1 and thread args thread args. Do I need to set something? Mailbox is empty, total mesh is empty. Read and write, okay. So I create everything, okay. Now, when I receive a value, I want to iterate through all the threads. Threads AI. So the thread args would be also in the let's also create structs and threads. I will have a handle for the let's call handle. So thread handle in the threads args pointer to threads. Okay, it seems that fails. So let's continue since it failed offline, whatever. Let's see. So the threads args. Okay, so thread args. I will create an array of threads. Handle and the threads I threads threads args threads args. So I can have a way to reference the mailbox because I need to send a message. So let's write this one. Send message. The message in this case, it is a number. So the message size, it is the same, and instead of the actor, I need a thread pointer. So I have the right index, same instead of capacity here. I do this, right index, okay, actor mailbox. Okay, things should be the same. Args. Thinking instead of args, I could be actor. Could rename to actor. So known as okay, so receive. So I have the threads. Now I have the threads args. Dot. This is the threads args. Is the actor. Then I send message. The actor. The message itself, which is this. But I need to convert first to a number. Message. Convert ASCII to convert ASCII to ASCII to let's see. Let's ASCII table. The internet's a little slow. Okay, so the 7, it is 55. You can see that's the decimal. So to give 7, I need to basically 55 minus 7, it is 48. So if I want to change the correct number, I just do minus 48, then the correct message. So message, and then I do, in this case I will do every thread, let's say one thread for now. And the size of the message, it is 32, but I can do the message, right? I think that's it, and then I send this. Let's see, there is errors, a lot of errors, because it is different the types, unsigned long. Okay, so the thread ID, where is the thread ID? It's probably unsigned long, if so, this, right? So this kind of errors, it's so annoying. The right index is not a member of threads because it is thread args. What is complaining here? Okay, so it is unsigned U64. So here's it also I think it's signed, so let's look back here. Yes, it's signed. The total message is also signed. Only the read index that is not. The sending message. So in this case, I don't need pointer. I do this. So right click. And the mailbox is not a point. Okay, so take the address, put red arc. I forgot the microphone. Send message. Red arcs pointer. A is not you. Wait, what? Is used right here. Not initialized. It is initialized. So maybe this. So it started the threads. Okay. Let's. It's spinning, and receive result -6. It receives. Where? So received. Okay, so that's the wrong one. Okay. Let's test this. Okay, 7, result 14, after accept. Okay, so what about 0? It is, wait, what? It's crashed? But I'm catching this exception. Maybe I need to remove this. Let's try again. And it works. So accepts result. Okay, so that works. It didn't failed and restarted the thread. That one, so 100 divided by 1 is 100, and it is the correct result. Okay, that's cool. So you have a very basic mechanism for retrying operations. And instead of using one function, I want total threads. The threads total message. It is total messages. Total message is signed integer. Message. Okay. Message. So the current thread with fewer messages equals, let's say, is the first one, first index. So index of the better to thread index with fewer messages. So I need to store the min messages. There needs to be a big number. There is a int max. Let's see. Integer limits. Okay, find it int. So it's unsigned is long. I actually assign it the maximum value, and I need to check if the total message is is less than the minimum message. Then I set the index with the current index, and the min messages, it is equals total message, right? So while this is happening, it will change in the meantime because the threads will be running. So it's not exactly accurate, this index, but that's okay. And I don't need this loop. So receive buffer, okay. So the actors and message. So I have a way to distribute this. It would be nice to have a way to receive the value. So maybe another thread to just send those values. No. Instead of actually doing this here, I need to send here. So I need the client ID. So this is the response. Okay, so let's change to receive integer, and I need a way to I think it's printf or something. Let's try buffer. Let's say 1000. I don't know. So buffer the response and the result. So basically, I will format this like in printf. You format this passing any argument that you want here, and then copy all in this buffer. And then I can send this to this one, and I can basically say 1000. Okay, and failed. Okay, so I need a way to get the client index. Okay, so I think that the mailbox should receive both the the index, client index, and the client sockets. We can move these up to be able to reference. Define prefer size. Okay, so this will be from the actor mailbox, and instead of B, it will be message. So I need to change this to be a message. And this message will have the message dot value, and this is the message dot client index, right? So let's add here another struct, type def struct message. The first is the value, and the second it is the client index. Client index it is into, don't need but client index. Okay, so instead of this is array of messages, right? So I have message value, client index, that's right. Now I want to I need to so I need to change here the message is the message the value and the client. So this is unchanged. This looks correct. Let's actually schedule send message to the I don't think this needs a comment. Okay, so handle header. I think it should work now. Let's see if it compiles. Of course not. That is not a literal. It's not complaining. message value. I don't remember if it is printf. It is not literal. Let's see. Close S and printf. So is the buffer the size of the buffer? So this the okay, so what? String body. Yeah, it doesn't. Yeah. So if I need to do that, no. Then I need to write like this. Then fire. Oh, it's not. So it is not a member of threads. Total message. It is threads cards total message. It is a pointer, so this identifier I is not. So it is this. It's not possible to convert from message to S32. Okay, so mess, right? Okay, and let's test this. So it doesn't return anything, and it closes. Wait, what? So let's try it with 5. Okay, 20. Okay, that worked. All right. All right, let's go. Okay, so it worked, returned, and that's basically it. So let's see, let's think. So I guess that I managed to implement everything. The only thing that it is not set. So let's implement message, sends message. Okay. So if I set for non-blocking, so let's set the server to be non-blocking and then the client. Client connected. Okay, so you need to remove this. Okay, it works. So what I want to do is to thread test this, and there's a tool for that. Where I was testing this. Yeah, so actually I think I can get the let's see, benchmark. Okay, so let's write another test.bat. Instead, let's do this. Okay. And I want to set, there is a number of connections. Where is the options? Number of connections, so the default is 200. Number of connections to run concurrently, default's 50. Okay, so actually I can test it. Open another terminal. Let's run the server. Let's see. It is not accepting. So it is not working. Maybe because I need. Let's decrease the number of threads by 2. Because this is running at full speed. I could do a sleep. Or maybe a semaphore for waking up when there's a message. But for now I just want to test this. Let's see if it works now. Okay, so it's not connect connections. Is not number of connections. So okay. Is refusing. Maybe because I forgot to add the ports. Yeah, I forgot. It's not running. We'll receive the same. Test. Maybe I need to close the connection. The client index. Okay, all right. So it worked. It didn't generate. It didn't generate anything. So it was pretty fast for 10 connections. Let's see if we can do another. And it died. Why? Okay, and then it simply disconnected. ID 12. It's not accepting more than 12. Okay, so it's just received 8, result, point connected. Success rate 95%. It's request per second is the average of 2000. So there is one connection error. let's test with the 200. And it simply disconnects. So where's the, so 2%? I would need to understand why it's happening this. So when I was not doing this, can I run? It's still error reading body from connection. 0%. Okay, so there's no error. So you see. Okay, I think that so there is 200, not 200, but 20 connections, and each that sends several requests. And the problem is that I only send this when I accept the the client. Let's see. So I need to move this out. For it disconnect. So the client connect. You basically receive the message, print, set the thread to execute, send the message. And go back to step 1. Okay, so send failed with it received the smile face. So if I don't receive anything, I just go back, yeah. And I only send because, okay. So I think that should do it, yeah. It connected a lot of clients, but nothing. It seems stuck at 50. So I am, okay, so I see. I'm actually only receiving from one client that is not. Okay, so I need to iterate the client I less than, I think it's max client plus plus, and then this. I move all these to here. Let's see if so is it. Okay, so I set non-blocking for the client. Okay, so I forgot to update here. Yeah. And there is connection errors, and it failed. So it's not max clients, but client index, because I'm iterating the clients that are not connected. Client index is it's not unsigned. It's used as an error. So it receives result. So none. Okay, there is one that received 0 and couldn't. Oh, so that's why. So let's change something. Let's test without the 0. And fail with error. Send failed error. Not a socket. The client in the probably I'm missing something here. So 0. Oh, it's not the threads. The index with the... Yes, it is the threads. This client index. Okay. So actually, okay, if this is I client index and value. Can I just do this? Yeah. It doesn't work. I'm iterating through the client, the current client. Receive. There's nothing to receive. I continue the loop. Red arrows, actor, send message, the value, the client index. So it's still synchronous, I believe. Max clients. many characters does this have? $108. 600. Yeah. Okay. So but there is no error. What's the maximum connection? That's a lot of connection. So it's not this. So it's connected. Um, it's not sending. But it's also not printing. Okay, so let's test it. Okay, so this works. A bunch of nodes. It's okay. receive bytes received and overnight server. Accept client. So it accepts one client. If it receives 0, then it closes the connection. Where is the less than 0 and else if results equals 0, let's close the connection. Let's so it works, but doesn't recognize. So it's not that. So I actually found the article that I was talking about. Is actually the Riot Games company. It's for the League of Legends. Yeah, so they created their own kind of internet to fix the not to fix but to make a better experience for players, and it's really interesting to read about. They explain their problems and how they managed to solve this. So I really recommend looking into this. And the next thing, I managed to make it work. I was not doing handling correctly when the accept was failing. So if it is a valid socket, then you just set non-blocking and add the client index. And if there's an error, I just basically continue the loop, don't go to read here. And and you can see that now it works. So let's test and manage to handle it's 200 requests. Okay, so request per second, it's 900. 100% success rate, and let's see. So 200 responses. So it works fine. But if I go over the number of max clients, it doesn't work because it grows upwards, the number. So what I want to do is to actually recycle the sockets. So you can see that I can I close the socket and then set to invalid in case if it disconnects. And let's see. So client index doesn't work anymore. Should be max client. And I need to know if it is a valid socket. So it is not. If it is invalid socket, I continue. That's the first thing to do. Okay, so let's close the socket here. Client socket. Also invalid socket. And here, after sends data, so I need a way to have a free list of the available sockets. So I have a free list. I need free list sockets. And these will have max clients, right? So I receive so instead of doing this, I just check if it is accepted socket, and I don't think I need these anymore. I need to make sure that it is a valid one. So accepted socket, but instead of So I need a way to get the current tree. So if, okay, so I can, I can increment the client index indefinitely. What I can do is check if the client index is greater than max client, greater and or equal max clients. Then I need to use the free list, otherwise I can just do the regular client index. So the free lists 0 is the index and that's the, I need to do this. So I can say accepted sockets instead. Accepted sockets. So I don't know if it is this or this one. Accepted sockets, update the client index. So at first I go in order, and then after that I need to check this. So I save the index, this, set the client, set the sockets, and now I need to grab the next one. Or should I do a stack? Free list index, then free list index minus minus, free list index equals 0. Okay, so it's free lists free list sockets, free list index equals I, and free list index plus plus. So basically I need to do every time there's invalid sockets. Where is the here? So I need to do this and also this, right? Instead of I, it is So this is accepting if client. Then I need the free list, otherwise it should be using valid sockets. So the free list if free list index greater than max clients, so it is fading again. So it accepts the socket, check if it is not invalid. It is greater than or equal to max client. It should use the free list index to get the index, and then client sockets index, accepted no socket, print that index, and then I remove from the top. Otherwise, you just use the client index, accepted socket, and accept the socket, set on blocking. So it is not that. The client index plus so iterate if it is invalid. Okay, so not everyone it is invalid at startup. So client socket invalid. Okay, so everything's fixed now, and I want to. I have 2 million maximum clients connection, and I'm sending 200,000 requests, and let's see if it's faster with this option to run in parallel. So let's start the server and finally test. Yeah, that would take too long. So let's try 10,000. So 200 requests per second. I wonder if I change. Let's see, 5,000 requests. So 300 requests per second. The average of 0.1 seconds for that, and let's test with the 0. So it crashed. So it's having a connection error. You're supposed to to catch that, but for some reason it's not. Yeah, I don't know what is happening. Finish. Finish free. So I think it doesn't work exactly how I thought it would be. So I don't think it's working as expected, but I think that was an interesting experiment. And so I think that's it for today.